Okay, so 2.6 math models, basically finding out things that model math used to model reality. So question number 1 says, all right, start with the curve y equals x squared minus 6. So you got a lot of graph knowledge now. We've been talking about graphs for hours. So you can look at that and have instant knowledge now, can't you? What does that thing generally look like? It's x squared, it's a U shape. Where's the center of it?
6.
What's this minus 6 going to do?
It's going to go
Is that up, down, right, or left?
down. Oh, no.
It's down, huh? Because it's not in there with x. So it's down 1, 2, 3, 4, 5, 6. There it is. At down 6. Let me draw it. Like that. So there's what you're looking at. You know that right away because you know graphs. So it's at down 6. Now, what are we going to do from there? So that thing's down 6. So now, they're going to say, take some point, x, y. They're going to say, let P equals x, y be a point on the graph and find the distance from the origin. They're going to say find the distance from the origin.
This is the distance formula.
Yeah, exactly. So here's the origin, 0, 0. And so what they're asking me for is what is the distance from 0, 0? What is that distance there? From the origin, 0, 0, to some point x, y on the graph. Well, yeah, we're going to have to use the distance formula. Do you remember that from your algebra days?
No. Isn't it like x2?
Think, are you kidding, Mr. Heron?
It looks like slope.
It's kind of like slope. The distance is, anybody remember it?
Yeah.
Root?
X, y2 minus y1, x2 minus...
Right. x1, I'll just write it this way, but you're totally right, Abdul. Like that. Difference of x is squared plus difference of y is squared, and the whole thing rooted. There it is. I don't like to put math on the board like it's magic. Really super quick because we don't have a lot of time. Where did they come up with that? If you had just any 2 points, call it x1, y1, x2, y2. You had any 2 points on an axis system and you wanted to find the distance between them, how did they come up with that formula? What did they do? Have you seen this derivation before, how they came up with it? They just said, look, we just make a right triangle. It's just going to be the hypotenuse of a right triangle. The distance between 2 points is just the hypotenuse of a right triangle. Okay, we can use Pythagorean theorem, right? But we got to get the bottom first. How far is it from here to here? This is over x1. This point is over x1. This point is over x2, right? So what if this was 3 and 7, and I asked you how far between them? What would you do with the 3 and the 7?
4.
Subtract them to get 4, huh? So you would take x2 minus x1, right? This point minus that point.
Mm-hmm.
And how would you get the height there? This point is at a height of y1. This point is at a height of y2. If this was 10 and 6, what would you do to get the height between them?
Y2 minus
Subtract them. y2 minus y1. So this side is y2 minus y1. This side is x2 minus x1. This side's the hypotenuse of the right triangle. Now we just do the Pythag. I just want to show you how they came up with this. So they just said this squared plus that squared is that squared, huh? So they just said x1 minus x2 squared plus y1 minus y2 squared is distance squared. Then they wanted to make it regular distance, so they rooted it. And that makes it regular distance. It gets rid of the square. That's how they came up with that formula, huh? Oh, and by the way, if I write x1 minus x2, that's no difference than x2 minus x1. It's okay either way. Why is that? Why are these the same? Because the order of subtracting, if you take 7 minus 3, or 3 minus 7, it's just 4 or negative 4. It only makes a sign difference. And then since you're squaring it, it's going to be negative 4 squared or positive 4 squared, which is 16 either way, huh? So that's why the order doesn't matter, whichever way you want to write that. All right, so we have the distance formula. Let's go back. So I'll put it back up here. We have the distance formula now. So we can find the distance from 0, 0 to some point xy. So call this x1, y1. Call this x2, y2. The distance will be the square root of 0 minus x squared plus 0 minus y squared. So far, so good? Maybe I should have written it up here better for you. Square root of x1 minus x2 squared plus y1 minus y2 squared. Right, because x1 is 0, x2 is just x. The x2 is just x, x1 is 0, y1 is 0, y2 is just y. See that? That good so far? Simplify that a little bit. That's just square root of x squared plus y squared, huh? Because negative x squared is just x squared. Okay, good to there. Now that would be great, and that would be the answer, except they ask me for one more thing. They say to me, to us, what do they say? Oh, I didn't write down. They wanted only an x. They don't want a y. They say make it a function of x only. So I've got to do something about that y. I've got to plug in for that y some x stuff. How do I do that? How could I plug in stuff for that y there?
Y is equal to x2 minus 6.
Good eye.
X to the second minus 6.
I just plug that in for y, because they want the formula only in terms of x, no y. So we know y is equal to x squared minus 6, right? Because this point is on the curve. So if you're on the graph, then your y value is equal to your x value squared minus 6. That's what it means to be one of those millions of, all those millions of dots on the U shape. If you're on that U shape, then your x and y coordinates have that relationship. That's what a graph is a relationship. It's like a friendship. It describes how the two relate to one another, how the x and the y coordinates for any point on this graph. You know, if this was just some point x, y just like floating out in space, then we could not use that equation. But it isn't. It's an xy point on the edge of the U shape. So since they told me that, that allows me to use this equation, which is true of any point on the U shape. So I plug in there, and I do a little bit of algebra. So I'm going to get, this will be the square root of x squared plus, and then what is y? X squared minus 6 squared.
Oh, absolutely.
So let's do a little bit of algebra. So here we go. I'm going to have to actually make that, square root of x squared, and then make this x squared minus 6, x squared minus, right? You got to write two of them in FOIL. Whenever you have a 2 on a parenthesis, you got to write 2 of the parentheses and FOIL that whole thing out. So boom, 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 boom. So I'll get square root of x squared plus x to the 4th minus 6x squared minus 6x squared plus 36. We good to there so far? You okay with that algebra mess?
Yeah.
It's gonna be kind
I feel like I'm dumping a lot of math on you this hour and 15 minutes. It's a double section day. Hopefully we don't have too many of those in the course. All right, and now I'm just going to reorder them, highest power to lowest. So I'll grab the x to the 4th, put him in the front. And then I'm going to combine the x squared terms. This is 1x squared minus 12x squared is minus 11x squared plus 36. We good? All is well. So there's the answer to part A. That's all just part A.
Oh, okay.
They wanted us to come up with this formula. Now, what is that formula? It's the distance. Remember, I kind of lost the word. It's the distance from the origin, 0, 0, to any point, x, y, on the U-shape. That'll tell you the distance. Now, in parts B and C, they want us to use that equation. They just want to see if we have a feel for what that thing is really doing. So let's do that. Let me draw another picture for us. Still on number 1. So, and they're going to let me draw the U shape again. So, and we're from the origin. any point x1. So this is the distance. And the distance formula we now have is the square root of x to the fourth minus 11x squared plus 36. Right? So now what is that formula? Well, how that formula works is you give them an x, it'll tell you the distance. So let me try to make it real for you. What if I said, hey, I want us all to figure out our distance from the door, from this front door, in the room, right? So Naz is about, I don't know what Naz, maybe 6 feet from the door. So Naz is maybe 6 feet from the door. And then I would just, each person, then maybe you're or 7 feet from the door, and maybe 7.5 feet from the door, and boom, everybody would have a number, about how many feet they are from the door. So that could be like a function. I could say, you give me your name, Samuel. And I'll say, okay, Samuel's 12.6 feet from the door. Right? So that's what this formula is like. You give them an x, you give this thing an x, it'll tell you how far you are from the origin. So I can say, oh, okay. So like, what if I'm right here? That's an x value, I don't know, maybe it's 7 or whatever. I'm at a point with an x value 7. I don't even know what my y value is. And I plug in a 7 here. If you work it all out, it'll tell you the distance that point is from the origin. See how that thing's working? You give it an x value, it tells you distance from the origin. Okay, now, with that in mind, let's test it out and see if it's working well. What if we, look at this point right here. Remember, this is the graph y equals, kind of scribbling here. This is the graph y equals x squared minus 6. So this is the point negative 6. Remember, that's where the U shape started, down 6. So if that's the point y equals x squared minus 6, how far is that point from the origin? What's his distance? Well, we don't say negative for distance, If I said I drove down to LA, I drove negative 200 miles. Nobody talks that way, right? Because it's south. Nobody. So distance is just positive. So the distance is just 6, What's the coordinates to that point, like the x, y coordinates?
0.
Over 0, down 6. So his x value is 0, isn't it? So that means, remember what I said this formula we just came up with does? You give it an x value, it'll tell you your distance from the origin. So if I plug in 0, because this guy has an x value of 0, he better tell me 6, because I know his distance from the origin really is 6. It's a good way I can test my little formula, see if it's working. What does he give me?
He gives 6.
So 0 to the fourth minus 11 times 0 squared plus 36 is just the root of 36, indeed is 6. He's working. See how that formula tells you your distance from the origin when you plug in the x value? All right. Well, their part C, they want you to plug in another number. I'm going to jump right to the real conclusion to the matter. Now, here's the real question. All this was built up for this question. Which point on that U shape is closest to the origin? That's what they really want to figure out. So if you're looking at that big U shape, there's a million dots, right? This dot, how far is he from the origin? He looks a little closer than 6, doesn't he? Right, this one's 6 away. This one looks like, I don't know, 5 something, I bet, if we plugged in. It's a little closer. This one, I think the closest point is about here, and I think you have the same thing on the other side, don't you? I think the closest points to the origin would be about those two, probably. Right, this point is far from the origin, Are you with me? We're trying to find the point or points on the U shape that are closest to the origin. I'm guessing it visually looks like it's this point and the same thing on the other side because it's symmetrical. Those look like the closest points to the origin, right? Their distance from the origin is what? Minimum. Do you see what we have to do? How do we find it? We've got to take that distance function and we have to minimize it. That's how we find closest. That's what closest means, right? If I said, who's the closest to the overhead projector in this room, right? It would probably be Olga, right? It's right underneath the overhead projector. Her distance from the overhead projector is the lowest distance, right? My distance from the overhead projector is a much bigger number than Olga's number, right? So when somebody says find closest point, that means minimum distance. That's what closest means, lowest distance, huh? So how do I take this distance function and minimize it? How do you minimize something?
Make it small.
Can you factor something out?
Well, in calculus, they have a way. It's called take the derivative and set it equal to 0. But this isn't calculus. That's next semester. That's how you would do it by hand. We can't do it by hand. So we did minimum last week. Remember? We're going to do it again. So put that into y1, graph it, and hit minimum. That's how we'll find it. So put that thing into y1. So we're going to go y1 equals square root, then you got a parenthesis, of x to the fourth minus 11x to the second plus 36.
Should we make the window all 10?
Yeah, make it just negative 10, positive 10, negative 10, positive 10. That'll work fine. Graph it and find the minimum.
No.
So when
And it'll work fine.
when you put the parentheses in, that just means everything is under that square root.
Everything's in that root. Exactly.
The square root
So put that in. You should get a kind of a W looking graph. It looks sort of like a W.
Do you have to put the parentheses in on the graphing calculator?
Depends on your calculator.
Probably if it looks like it's under that.
Do the new ones show it real nice? I think they do root automatically, don't they? I mean, a parenthesis automatically when you hit root. So get that in and hit graph. Give you a second on that. Let me draw it over here. Yeah.
So I was thinking of the minimum as like the lowest point on
It's the lowest value of that.
the lowest value of that. Okay.
So I'm getting a graph that looks sort of like this.
Yeah.
You getting that? My window, again, is negative 10, positive 10, negative 10, positive 10.
That looks like an activation.
Is that good? So I won't even, I don't even need to show it. I've got time for that anyway. So anyway, and we want to find what? This point right here, or the other one. Let's just find that one. They're going to be the same. They're going to be these 2 points that we observed. So find that point. How do you find minimum? Remember, you got to hit second calc. So maybe I will show that. Second calc. Remember how to do all that? Second calc, and then go down to minimum and choose minimum, and then you have to go left of the min. Like you got to go over here somewhere, and then you got to go left of the min. You got to go right of the min. Remember, and it does those arrows because you're setting up a search zone. And then you just hit enter. For the guess, you just hit enter. It goes left bound, right bound, guess. And then you'll find it. And I'll just tell you what that answer is. 2.35?
Yeah.
I think I remember. It's 2.35 for the x. I don't remember what the y is.
2.39.
Rounds to 240 or something.
Yeah.
Yeah, 2.40 for the y. You getting that okay?
My isn't connected in the middle. So it was just to use on the quadrant 1 and quadrant 2.
I can look at that after with you. So we good there? Is that making sense? So the answer to the question is that they just want the x value, 2.35. That's the point. The point that's over 2.35 and I don't know what his y-coordinate is the point.
Okay.
Oh, wait, do we know what his y-coordinate is? It's this point right here. He's getting bigger every time I shade him. He's a monster point. So, what's his y value?
2.4.
Really?
Oh,
Doesn't it look negative?
a negative 2.4.
Is that what your calculator told you?
No,
Mine either.
This one.
What's going on with that, guys?
it has a vertical.
What's the y value of this point? Did you get this for x and y?
Yes.
But isn't that y value negative? Isn't that over and down? So why is the calculator telling me positive 2.4?
Because it's never touching 0.
Doesn't matter with this one, right?
Oh, well, it's cut, yeah. It's
Look at your
Because that's not the y value.
Oh.
What is that? That's the distance.
Oh.
I want you to realize that. So I want you to see that's distance. Why? Why is that distance? So this is where you've got to be the intelligent operator of technology. This is how it works in the real math science world when you're using computers and fancy programs to do things. You always have to know what's going on, though. And so to know what's going on, this is the distance. We just typed in the distance. We put into y1 the distance formula. So this is x comma distance, not y values on the graph. The y values on what the calculator graph are distance, because so whatever you put into y1 and tell the calculator to graph, this w graph is showing you distances. The y values are y1 values, which are what? Distances. Well, then how do I find the actual y value of this point? You can take this x and plug it into the original equation if you want it. They're not asking me for it, so I'm not going to mess around with it. But that's how you would find the actual y value of the point. Does everybody see that difference? I just want you to be aware that when you type into a graphing calculator and tell it to graph, the y values are whatever y1 was told to do. It's just doing what it was told. And y1 was distances. This is a distance. In other words, 2.40 is how far that point is. It's the point over 2.35. I don't know what the y value is. And its distance from the origin is 2.40. That's how far away it is from the origin. Make sense? All right.
So we're only going to have one section do on?
All right, so here it is, number 6. All right, so number 6 is a big old box. Oh, it's a flat piece of cardboard, and they want me to, I'm not sure. All right, so there it is. So what they're doing is they're taking a flat piece of cardboard. Let me actually do it with my little piece of paper here. And they're going to rip out the 4 corners and fold it up into a box. They're going to make a 3-dimensional box out of it. So I'm going to take one of my very valuable syllabi here, and I'm going to take this like a piece of cardboard, a square piece of cardboard, and I'm going to rip out the 4 corners like they are, the 4 X's, you know? So I'll rip out same size from all 4 corners here. So it's 1 corner.
Okay.
And basically they're saying, how big should you rip out the corners? Because depending on how you rip out the corners, you'll make different kinds of boxes. And in the end, we want to make the box that'll hold the most.
With the biggest volume?
Biggest volume. Very, very practical question.
Yeah.
Companies that ship things in expensive metal containers that take big metal sheets and make them into 3-dimensional objects, if that metal's expensive, they want to make it in a way that'll hold the most and use the least material. Very, very, we're getting practical now. You guys have got enough math under your belt now that you can answer real life questions. It's kind of like we're studying this foreign language called math. It's like we're studying, say, Chinese or whatever, and we've got enough Chinese now to where we can do fun things. We can watch Chinese plays now. We can watch Chinese movies. We have enough language to really do interesting things. When Algebra 1 students ask me, Mr. Heron, what are we ever going to do with this? I don't know what to say to them. They got to get more language. That's like a student in Chinese 1 saying, does anybody use this in the real world? Well, yeah, Chinese people do. They do things with this. But you've got to learn more Chinese, right? Same thing with math. You've got to learn more math. I tell my Algebra 1 students to see where this, and now you're arriving. You can see some of the real things. You got enough math now, you can do some real things. So this is something that companies actually hire math science people to do, to figure out the best way to do things like this. So how should we, so we're going to rip out the corners, and we're going to fold this thing into a box. And it's going to hold stuff. And if we rip out more from the corners, we make a taller box, don't we? But it's got a smaller base. If we rip out less, we make a shorter box but a bigger base. There's got to be somewhere in the middle where you're going to make maximum volume.
You rip out 6 by 6.
So how do you do
You
it?
list 12 in class.
So let's see. So with the shortness of time, this box is 24 all the way across by 24 tall. When I rip it out, first off, what's the volume? What's the volume of this three-dimensional box? Do you know the volume of a 3D box? Length times width times height.
Oh, that's what you meant. I thought you meant the actual number.
So that's what it'll actually hold. Any box will hold, whatever length times width times height is. And now, how do you figure out length and width and height? Basically, this dimension, let's call it width. And this dimension here, we'll call that length. What's the width of the box? Looking back over here, it's this right here, isn't it?
Right.
That, right? Because you rip out this and fold it up. Mm-hmm. So that's width. So what is that width?
It's like 12.
24 minus 2x.
Huh.
Do you see that? Because all the way across is 24, isn't it? Outer edge to outer edge is 24. Back up x to get inner edge to inner edge. Do you all see that? Right? Because it's 24 originally, but I cut off x and cut off x. So that inside is now 24 minus 2x, isn't it? Mm-hmm. And it's the same thing here. It's 24 minus 2x. And what's the height? It's just x. You see, the x that we cut off folds up and becomes height, doesn't it?
Right.
So there's my length, 24 minus 2x. My width, 24 minus 2x. My height is just x. There's your formula. You can type that into to your calculator and hit minimum, and you'll find the best box. We're out of time.
You type it in your calculator.